Okay, so in this video, I'm demonstrating how to set up your Excel file. So for each experiment, you can set up a separate file, or you can include multiple sheets on the same Excel file. You can use online Google Documents for that. So here, make sure you include your name and the title for the experiment. If you have put multiple experiments in the same Excel file, put all their names. So you will analyze experiments 17, 20, 21, 22, 23, 24. So altogether, this is 6 experiments. Um, Now, the data here is it's a made-up data, so your data will be different. So you read the data from the graphs, right? This is for the position X, the same way you read for position Y. And for each interval, you will find the speed or velocity by dividing the position by the time, okay? So here, as you can see, as the time increases, the amount of displacement increases, right? And thus the speed is increasing or velocity is increasing. Um, Now, let's see. Uh, this should give us the idea about average velocity, right? If we need to find it. The next graph is about velocity. So velocity is changing over time. We see it from here. So you're going to use the graph to read the numbers. Again, my numbers are based on something else. And for each velocity, you will find acceleration. Okay, so for each interval, so from 0 to 1 is this acceleration, from 0 to 2 is this acceleration, and so forth. So the formula should be included inside the cell, so this way you don't have to compute them by yourself. Excel will do them for you. Same thing over here. Okay, and then for this one particular one, you will have to find average acceleration. For this one, you can find average velocity, so I can just copy this and paste it here. Let's see what's going to happen. So we can check this. Yes, indeed, it's getting the average of all these values, except we have to change this average velocity. Average velocity expressed in meters per second, like so. Okay. Next, here we're analyzing position Y. Basically, we have to demonstrate that the position is not changing much. Y position is perpendicular to the direction of the slope incline. So again, I made up these numbers. They're quite small, and for this set, you will analyze them using mean square root analysis to find the standard deviation. So first, you list all the data points, including time and position, find the average. Then you, from the average, find the delta y, how much it is deviating. Each number is deviating from the average. When you put this, make sure you put the dollar signs like so. So this way, this number will be compared to this number. Each of these numbers will be compared to this number here. Once you're done with this, just copy and paste. And obviously, you will have probably more data points than I have here. You have to find the sum. Okay, so it shows you it's quite small. It's basically virtually zero average error. Now you're gonna square each of these values. Here it shows that this value is squared, and they're gonna continue this for all the numbers here and find the sum of the squares here. Once you've done that, you're gonna use that square, the sum of the squares, and find standard deviation by dividing the sum by the number of data points and then square rooting that amount. So there it is. Now you're gonna do the same thing for the so at the end you can write down position is equal to blah 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 plus minus this. This is virtually zero because the error is greater than the position. Now, it doesn't mean the air is greater than the position. It's just this is closer to 0. And this is how far it is from 0, essentially. For the y velocity, you're going to do the same thing. I put the numbers in. Find the average velocity here. You can use scientific notation to make the numbers like take up less space, right? And then again, average. Let's see if I spell average correctly. Average. Okay, so this is going to be average. And this will be also average. Average, right? And then also similar calculation. Basically, you can just copy and paste this thing. You don't have to copy the formulas, but make sure they use the corresponding cells, right? So this sum is summing up these numbers, right? Again, we don't want to include the words, so make sure that's the case. So for this one, I guess we have to also make sure manually change this to this. Okay, so this is the sum of squares of delta y, delta vy, I should say. So you see, I copied that and then changed the variables. Then we do the same thing, sum them up, right? And then find standard deviation by dividing the sum by the number of measurements and squaring it. Finally, Vy is equal to this number plus minus this number. So as you can see, y velocity is negligible. It's quite small. So this way you can say we can ignore motion of the ball along the y-axis perpendicular to the incline and focus our attention on the motion along the incline and analyze like the speed, how the velocity is changing, and then how acceleration is there different for each slope. Okay, so complete this part and then save it in your online docs. We're going to discuss it in our live session next week.